So let's continue with scripts now. So what was the disadvantage of running things on the command window? The disadvantage of that is that each line is only executed on its own, right? So like if you want to write a program here, it's not going to be very efficient. Now, what's the best way of writing programs is writing a script, right? The same way that you write C++ or Python programs. You don't run them one line at a time. We don't write them one line at a time. We write the whole program and then press run, right? So the way this works in MATLAB is just like using a script. So you can create a script, or it's also called M file, M short for MATLAB. So here you just have a page that you can write your program here. That's called a script. So it's basically a file containing a series of MATLAB commands. For larger, more complicated tasks, it's better to write all commands in a script file rather than writing them in the command window. Once you run the script, all the commands within that script will be performed sequentially from top to the bottom, right? Unless you have loops or ifs, otherwise everything is going to be run from top to the bottom. So any MATLAB command can be placed in a script. You don't need to declare variables the same way that you do it in C++. We don't need to say like integer or float or character. You can just use variables very easily. So that's one of the things that makes MATLAB more user-friendly. In order to run a script, you have to save it. And the extension, as I mentioned, is m.m. So that's why we call this m file. You can write functions if you want, the same way that you do for C++ or Python or any other computer programs. And you can also like debug your program. We go through that very briefly very soon. And you can also use comments, and you can also sectionalize your program. So here you may use command edit to create a MATLAB file. So what I did was basically just go here and say new script, but here I can also write down edit, let's say puya.m, right? It would create I would ask me if I want it, and I would create a MATLAB file, m file called puya.m. So you can use edit as well to create or modify a script. If it doesn't exist, it would create it. If it exists, you can use it to open it and modify it. I already mentioned about advantages of a script. You can run it multiple times. You can debug it. Using some function called tick and talk, you can analyze the time consumption of your program. You can create breakpoints in your program to run the program up to a certain point. You can sectionalize your program and run sections. And these are like some of the advantages of a script. I already mentioned about these commands, clear all or clear all the same. You don't need to use all here, but like this is something that they use. Most programmers that work with MATLAB, they put it on top of their program to make sure that all the variables are cleared, unless you need some of the variables in your program. Otherwise, you can just clear everything, close all the extra plot windows that are open, and clear the screen. It's a very good practice to write comments. And sometimes if you have, for example, an infinite loop, or if a program is taking a long time, or like if your system halts, basically you can terminate the execution of a program using Control C. So this is something to keep in mind. The way comments work in MATLAB is using the percentage sign. So anything that comes after this, it's going to be comment. It's not going to be executed or compiled. Or if you want to make multiple lines a comment, you can do it with curly brackets in addition to percentage sign. So that's basically one way of doing it. Again, I'll try to use like some functions here. Some I already explained, magic I already explained. Flip LR, it just basically flips, mirrors a matrix from left to right, flips it from left to right. So for example, if it's 1, 2, 3, becomes 3, 2, 1. If it's 1, 2, 3, 4, it becomes 4, 3, 2, 1. Basically mirrors it with respect to the middle line between right and left. As I mentioned, you can create sections in your code and run each section separately by using 2 percentage signs. So here you see an example that there are 3 sections in this program. If you click on any of these sections, you can run the section separately and without running the other 2 sections. So that's one of the advantages of writing a script. Sometimes when you want to write a command or a function or a line of code, it gets too long, right? And you don't want to have a very long line in your program. So what you can do is basically put ellipses, like 3 dots, and that means that the rest of this line will be continued in the next line. If we don't write this, we get an error because it basically asks us like, oh, where is this ending? This is like, I see this matrix opening, but I don't see it closing. But if we put ellipses, basically it means that the continuation of this line, it's going to come later. Okay, so for example here, this is the same as saying A is equal to 2 multiplied by 3. I don't know why it says 3, it should be 6. This is wrong. This is, I can show you and make sure that this is should be 6. Oh, it's because everything is commented, right? So if I just like say 1 multiplied by, this is commented, that's why. If it was like this, then this would be 6. Yeah. So you shouldn't put it like in the beginning. It should be at the end, right? Because once you put this here, it doesn't make any sense. It should be at the end of a line. This is wrong. So So you can make directories in MATLAB using the function make directory, or you can just create it using Windows or any other operating system you have. You can also here go and change the directory. This is like where my working directory is, but you can change it here, and or you can do it textually using DOS commands like cd, or you can also open an M file using MATLAB from here, or create it use here, or you can use edit to create or modify a text file. Okay, so these are not very commonly used anymore because everything can be done visually, like using graphical interfaces that we have available. Let me close these so that like I don't want to say. Okay, so sometimes, let's say these variables that I have available in my workspace, I want to save them. So like if I clear, everything is going to be gone. let's say I want to keep these for certain purpose. So I can just say save, and I name the thing that I want to save these, like I want to give it a name. So like I'll say like saved variables. So everything, it's going to be saved under this mat file, which is shown here. Okay, and it's shown here like what's included here. Now let's say that like I clear my workspace. I don't have any variables anymore. Oops, sorry, CLC. Yeah. Now if I load the saved variables, everything comes back. So save and load can be used to save um, all the variables in your workspace, or you can specify that I want to only save these two variables, let's say only A and B, or I only want to load A. So that's another application of save and load. So similar to any other programming language, when you write a script, many times we want to have conditional statements. The most famous conditional statement is if, else, or if, else, if, else. And the format of this command statement in MATLAB is a little bit different from C++ or even Python or other programming languages. Any if block needs to have an end. Okay, so we'll see that like any block of program, we want to end it, right? And we don't need round brackets over conditions. So you see like that's one difference with C++. We don't need brackets here. And else if, you can write it just without any space, and else is the same as before. So here, like you check if A is bigger than 10, it goes here. If not, it goes here and checks if A is less than 3. It is not, so it comes here and B becomes equal to 2. So I'm not gonna spend that much time here because you guys are familiar with if, else, and else if. It's very similar, just the format is different. Just be careful that like else if and else are optional. Like you can have else if or no else, or you can have else with no else if, or you can have none of them. Like if A is bigger than 10, do this, end, right? So just be careful about that, that you don't have to have like else if and else in every if statement. Also, like we have options for loops in MATLAB. Oh, so I forgot to mention that it's good practice to do indentation. It's a very, very good practice. It's not mandatory, but it is, like in some programs it is mandatory, like for example for Python it is mandatory, but here it's not mandatory. But it's a very good practice to make your program more readable by putting indentation inside every block. So here this is the if block, we indent everything that's inside this if block, or everything inside this else if block, we indent it. We have the same thing for for loop. It's very similar to MATLAB, just it's very similar to C++ or Python, but the formatting is different. Okay, so one thing that we have is, again, when you start a for block, you need to end it. Okay, and what we do here, we basically have a variable, a counter variable or indexing variable, that's our loop index. Basically here we say that we want to have a loop for I, where I is going to be initialized with 2, and it's going to go all the way to 8 with the steps of 2. So how many iterations are we going to have inside this loop? I is 2, that's one iteration, then 4, 6, and 8. So 4 iterations. Okay, and at each iteration we do something here. That's basically the format of a for loop in MATLAB. You just have to make sure that you end it, right? You don't need curly brackets like you do for C++, but as long as you have a for and end, everything in between belongs to that for block. Again, indentation is a very, very good practice. Okay, otherwise other people would have hard time reading your code. Let's look at this example and see what's happening here. So A is zeros 1 to 3. So basically A is a matrix with 1 row, 3 columns. All the elements are equal to 0. K is equal to 1. Value matrix is a 2 by 3 matrix with the first row equal to 1, 2, 3, the second row 5, 6, 7. And I say for JJ is equal to value matrix. What does that mean? JJ is equal to value matrix. Value matrix is a matrix. Okay, now we'll understand. So first thing that we have, f print f, iteration. This is a placeholder for an integer, and k is 1. So it just writes iteration 1. Backslash n, as you remember from C++, it's basically new line. It goes to new line. Now it says a of k means a1 becomes jj1 plus jj2. jj goes through columns of this matrix. So jj first is 1 and 5. jj1 is 1. jj2 is 5. So a1 becomes 1 plus 5, 6, as you see here. Okay. It also writes prints jj, displays jj, which is 1 and 5. Sorry, I missed it. J is 1 and 5, and A is now 6, 0, 0, 0. Used to be 0, 0, 0, now it's 6, 0, 0, 0. And increment K. K becomes 2, is prints iteration 2. A2 is JJ. Now JJ is 2 and 6. So A2 becomes 8. And then A3 becomes 10. I just wanted to show you that you can have irregular loop indices, right? It means that JJ goes through columns of this matrix. One point that makes your program faster, if we compare these two, as we mentioned, we don't need to declare variables in MATLAB, right? So here, Tick and Talk are used to measure the time that it takes to execute this loop, right? In this case, we have a 2000 by 2000 nested loop, and over here a I and jj, so we want to create a 2000 by 2000 matrix, and every element is going to be the summation of the indices. So 1 and 1, it's going to be 2, 1 or 2 is going to be 3, and so on, right? In the second part, we have almost the same program, but we basically initialize and we give it a size. We mentioned to MATLAB that, oh, our A is going to be 2000 by 2000. It doesn't have to be zeros, it can be anything, but as long as we give it a size. Now look at the time consumption. This one is 6 times faster, almost, like 5 to 6 times faster. Okay, so if you like, because at this point in the first iteration, MATLAB doesn't know how big your matrix is. So basically it has to, every time it has to deallocate and allocate a bigger matrix. But over here, we already know that A is going to be 2000 by 2000. So those allocation, deallocation times are going to be eliminated in this part B. So matrix pre-allocation is a very good practice. It makes your program much faster. If you have a matrix that's growing within a loop, usually you get a warning. You don't get an error, but you get a warning, because it basically makes the time consumption very heavy, and it's not a good practice. Similar to for loop, we also have another format of loops called while loop, right? So while loop has a condition. As long as that condition is true, we stay inside the loop. Again, according to the format of MATLAB, we need to end it. It's a good practice to have indentation for the while block. And for the condition that's in front of the while loop, we don't need to have round brackets. Again, because this is very, very similar to C++'s while, I'm not going to spend that much time. But here, look at this. X is 2k is equal to 0. Error is equal to infinity. And error threshold is 10 to power negative 32. As long as error is bigger than 10 to power negative 32, we just want to make x equal to x minus sine x divided by cosine of x. This is how you can actually find number pi, right? So this is basically finding, this is a formula to find number pi. And it would just like stay inside the loop as long as the error, the difference between this number and pi, is bigger than 10 to power negative 32. Once it becomes less than 10 to power negative 32, which apparently takes 6 iterations, then it gets out of the loop. Two statements that we have, two commands that we have for the loops is break, that would kick us out of the loop, right? So it's just like basically if you hit the brake, it means that you're gonna be out of the loop immediately. Another command is continue. Continue basically means that it's gonna skip one iteration. So break kicks you out of the loop, period. Like that's it, you're done with the loop. But continue would only skip that iteration. It would take you to the next iteration. Okay. Again, these are very, very similar to what we have in C++. Similar to that, we have switch statement. It's a little bit different from C++, but switch case, we have it in C++ as well. Instead of otherwise, we have default in C++, and the formatting is different. Again, we have to end it. Again, indentation is a good practice. So here x is equal to t. We say switch x. If x is any of these, display x is vowel. If x is 2, display x is 2. If x is -1, display x is -1. If x is t, then display x is character t. Otherwise, it means that if any of these cases if all of these cases are false, then do this part. Okay, so switch case is very similar to the format that we have in C++. If you remember in C++, it's a good practice to put breaks after each case because we don't want the rest of the cases to be executed. C++ also has try and catch, which is used for exception in C++, but here it basically, if you know that there's something might go wrong with your code, then you can basically do try and catch a statement. Let's look at this one. A is from 1 to 5, B is from 1 to 3. I is 1 to length of A. Length of A is 5. Right? Length of B is 3, length of A is 5. So we try means that we go here, we try CII equal to AII plus BII. If it doesn't hit any error, we go to the end and it goes to the next one. So it adds 1 and 1, then 2 and 2, then 3 and 3, then II becomes 4. at this point it says C4 is equal to A4 plus B4, but B4 doesn't exist. B only has 3 variables, 3 elements, right? So this would have an error. So once you hit an exception, once you hit an error, it would take us to the catch block. The catch block would catch the exception, would catch the error, and it says that B is too small. Okay, so for I equal to 4 and I equal to 5, this statement is not going to be run. If we didn't have this, we would get an error, right? So many times, to basically continue with the program without hitting the error, try and catch is a very good tool to use. You can work on this exercise. Write a script that asks the user for 2 numbers, A and B, and then prints all the prime numbers existing between A and B in ascending order. You should not use the isPrime function. So we have an isPrime function that would give us true or false if number is prime or not. You can use the mod function. You would find the remainder. Okay, so this is a good exercise. Another exercise, write a script that generates a random integer between 5 and 3000 and then creates the reverse version of that number. This is a very good exercise as well. So for example, if the random number generated is 11254, your code should generate 45211. Okay, and we don't know how many digits this number might have. It might have 2 digits, 1 digit, 3, 4, 5. So that's why it makes it a good program. You guys are familiar with functions in programs, so we can write functions in programs too. What's the advantage of function? If you need to do a task multiple times, it doesn't make sense to write the same code multiple times. So you write the code in one function and you just call that function multiple times. Okay, and also like it makes parallel processing more possible. So like you can assign different tasks to different functions, and each function is going to be done by each one programmer. And so like you can just basically distribute the task among different programmers. So functions can accept input arguments and return output arguments, or they might not even have input and output arguments. They might just like do a task. Internal variables are strictly local to the function. So any variable that you define inside the function is only going to be defined inside the function, known inside the function. When you call a function, MATLAB only executes the portion of the function file related to the function and eventual subfunctions. Okay. So the difference between function and script is scripts do not accept input arguments or return any output arguments. They operate on data in the workspace. When you invoke a script, MATLAB simply executes the commands found in the file from top to the bottom. So when I first learned MATLAB, we had to write functions in different files, and we would basically call them, but now you can actually write your functions in the same file that you have your main script. Previously you had to have separate file for each function, but now it's not the case anymore. So this is a bad practice I have. It would be nice if I had indentation here, but for example here, this is a function that has 2 parameters, b and h, base and height. This is the name of the function. The same rules that we have for variable names, we have them for function names. So no saved keywords, not starting with number, no special symbols. And it also returns a number, right? The number that's going to return is going to be a. which is going to be calculated inside the function. So this is the two parameters, and then you call the function and you assign two arguments. So these arguments are going to be passed by value to b and h. So b becomes 1, h becomes 5. We go here, a is going to be equal to 0.5 times 1 times 5, and it's going to return. This is a local variable. A is a local variable. Now, whatever it's returned, it's going to be saved into A1, and A1 becomes the area of that triangle. So instead of writing this multiple times, if we have to calculate the area of multiple triangles, you can just call the function multiple times. Another example, again, example of a function taking two parameters, returning something. This is a function that doesn't take any parameters. It doesn't return anything. It just basically assigns this value to this variable. This is a function that takes only one parameter but returns two. So unlike C++ that each function can only return one thing, MATLAB functions can return multiple things because it's a matrix-based program. It's also a very good habit that once you write a function, you add in the first lines of the code inside the function, write some comments that like what this function is supposed to do. And even though this is a user-defined function, if you provide comments, if I write help drop, it would print all the comments that you wrote, right? So it would basically provide some information for people who are reading your program or using your program. So in order to make your program more readable, it's a good idea to add comments, especially for functions. More examples here. I'm gonna skip these. Oh, this is actually a good example. This is like a function calling another function. Okay, so over here we have a function called myrand that takes two parameters, returns two things. It would calculate A, and for S it would call another function. So you can call a function inside another function. So from here it jumps here and it calculates sum of all the elements and then goes back here. So you can have a sub function in a function. I mentioned earlier that previously you had to save your functions in separate files. That's not the case anymore. You can have multiple functions in a file, so this doesn't apply anymore in the newer versions of MATLAB. And you can basically write your functions at the end of your code, and basically you can call them as you want. So here, for example, this is like a example. This happened since 2016 version. This is a function that calculates the permutation formula, factorial n multiplied by n minus r. Is it divided or this should be divided? Sorry, this should be divided by n minus r. Anyways, this is just an example of functions. What does product do? It basically multiplies everything from 1 to n in this case. So it's just basically it's a factorial, right? Because this is going to be 1 multiplied by 2 by 3 all the way to n, so it's factorial. So here, like we have like some function remainder is the same as mod. It would just basically give you the remainder. Let's look at this function. So we have a function here, takes one parameter, returns two outputs. It would basically take the, oh, it's calling another functions, my mean and my median. Okay, so a function can call another function. This is just an example of one function calling another function. So just wanted to show you that when you get here, this line is going to be executed, then this line is going to be executed, but at this point you jump to this function. Once this is finished and returning a to average, then it goes here, then it jumps to my median, and so on. Sort basically uses quicksort to sort a vector. It's a built-in function you can use. Remainder basically finds the remainder of a division. Local variables are only available inside a function, and if you want to access them outside the function, that's not going to be possible. Like you might have two variables with the same name. One might have different scope than the other one. So you have to be very, very careful about that one. This is basically the same as C++ or any other programming languages. You can also have global variables. You can define them as global, and these variables, they exist in all the functions. It's a bad programming practice to have global variables. It makes life very, very hard for the programmers, especially when you're dealing with a large program. It makes it hard to keep track of the variables, so it's not a good practice to have. Persistent variables are basically local variables in a function that they keep the previous value. Okay, so let's actually assume that I'm calling this function by saying accumulate 4. So I'm calling this one accumulate 4. 4 is the argument. It's going to be passed to the parameter n, so n becomes 4. It goes here. It says that summa is persistent. Okay, so is summa empty? Yes, it is empty. So summa becomes 4. And it jumps here, and total becomes 4. Ends, right? Now let's assume that I call the function again, right? It goes here. This time summa or sum a. Why do I say summa? Sum a. Sum a is basically it's gonna be the previous value, which is 4. So it keeps the value 4, right? It's not gonna be empty anymore. So persistent variables are local variables that they keep the previous value in the previous function call. Okay, one thing that's good to know for programmers, this is true for any programming language, any function call, it would have some overhead time. So basically some time that you want to pass your arguments to your parameters, and some time that you want to return what you're supposed to return, right? This is going to take some time. So for example, if we do this calculation without a function, it might take this much time. If we do it in a function, it takes longer, right? It makes our program modular, it makes it neat and tidy and clean, but it has some overhead. So you have to consider that, especially for cases that time is very sensitive, time is very important. It's not that much. It's in the order of micros, like hundreds of microseconds, but it's still like you have to be be wary of this. One other thing that it's recommended for programmers is to test their functions or their programs not just for one input, not just like whenever like I want to mark a exam, like I see something wrong and I ask the student says like, oh, it works fine for this input, but your function is supposed to work fine for every input. So you have to consider different cases, irregular, maybe wrong inputs, and like you have to make your program as robust as possible. So you just consider what happens if uh, the user enters a very wrong number, right? That can my function handle that? So that's what I mean by robustness. You can go through this example to see what I mean by robustness. I'm not going to get into that. As I mentioned here, you can put breakpoints in your script or function, and you can debug your program one line at a time and keep track of your variables. That's something that we also could do with Microsoft Visual Studio C++ for different programs. This option is also available. This debugging example, you can do that. You basically create a breakpoint here and you just like run your program either step by step or just like from one breakpoint to another breakpoint. Let's have a pause here. Thank you so much for your attention. Let me stop this.